All right, when we were looking at the water footprint stuff, we had lots of different rates. Like it talked about gallons per day. And so just trying to wrap my mind around that. And so the other day I'm brushing my teeth thinking about it. And as I'm doing that, I look down and the water's running while I'm brushing my teeth. And I'm like, oh shit, how much water did I just lose? So this morning I went and grabbed a measuring cup and took out the timer on my phone. And I just turned on the water and watched it fill up the cup while I timed it. So I did that a few times. And so what I came up with after doing it several times, where's my magic pen? Probably hanging up in the right spot. Ah, there it is. Okay. What I came up with is that I filled up, oops, that's not a pen. I filled up 2 cups of water every, shit, I better look. I think it was 6 seconds. I didn't bring my phone with me. Anyway. Yeah, I'm 90% sure it was 6 seconds. Okay. So I did, my phone has that, you know, the timer has that lap feature, so you can just hit lap, lap, lap. And it came out like a round, sometimes a little over, sometimes a little under, depending on, you know, where I threw the faucet. But usually when I'm brushing my teeth, I don't put it on really high, and it's not on really low, it's just kind of on this in-between thing. And so I noticed, you know, every once in a while, I see my kids do it, my wife do it, I do it. I kind of space out brushing my teeth with the faucet still on. So how much is going away there? So that's a rate, right? A rate is just when we take 2 things and we divide them. So that's in cups per second. Now I could clean that up a little bit, right? So like 2 goes into 6 3 times. So I could rewrite this, just playing with fractions, not doing any conversions yet. I could say it's 1 cup every 3 seconds, right? And I can kind of separate the 1/3 from the cups per second. That's legal too. So if I wanted to rewrite this in terms of what happens in 1 second, what's going on with the amount of cups in 1 second?
Just divide.
Yeah. So I would just take 1 divided by 3. Okay. And if you do it on the calculator, what happens? Maybe it's calculator handy, or remember what 1/3 is, it's a decimal. Yeah, you get 3s repeating forever. Now it's kind of a pain in the butt because you got to round it. How the hell can you do 3s forever? So either you got to round it, or you could just say, hey, it's 1/3 of a cup per second, right? So I took a lot and I measure. I have a little 1/3 of a cup thing at home. So that's a measurement I'm kind of used to. All right, so that's going on in a second. Do you think the faucet only ran for 1 second while I spaced out brushing my teeth? No. Okay. So what does the dentist typically recommend for length of time you should brush? Anybody know? 2 minutes, could be 3 minutes, depending on the dentist, right? With kids, they tell them 3 minutes because they're not so good at it. Those little timers they have, they're generally, I think, 3 minutes. So let's go with Aaron's idea of 3 minutes. So what I want to do is I want to convert cups per second to cups per minute, and then see what happens in the 3 minutes. Okay. So not too bad. So I'm going to go with my unit rate here just for fun with fractions. So we're starting off with 1/3 of a cup every 1 second. And I want to change this into minutes so I can deal like with the dentist recommendation. So I'm going to have to multiply this by a fraction. Seconds needs to go away. So where does it go in the next fraction? In the top, right? So seconds goes in the top, minutes goes in the bottom, and then like Robert said, 60 is going to go with seconds and 1 with minutes. So that's just, these fractions are just a reminder, what do you do with the number you're converting by? You multiply by it or divide by it? And every once in a while I'm like, ah, shit, I don't know. But these fractions help me figure that out. So this says just take and multiply by 60. The ones in the denominator don't make a difference. So let's see, 1/3 of 60 on a good day is 20. Sound right? Okay. So my rate with my faucet, you know, in a kind of a middle setting, is about 20 cups per minute. Right? Is that what I got here? When I convert, seconds goes away. We're definitely in cups per minute, and 1/3 of 60 is 20. Yeah, that looks right to me. Okay. So, but then 2 minutes goes by. So basically, right, double top and bottom, right? So that's going to be the same thing as what, 40 cups? in 2 minutes.
That's
Okay,
as long as, like,
so what's that?
That's as long as like you don't like turn it up or down.
Yeah, so this is like, yeah, so this is not like as fast as it comes out of my faucet, nor is it as slow. This is kind of like right in the middle. I wet my toothbrush, you know, and then I start brushing. So let's say I space out for that whole 2 minutes. I just lost 40 cups of water. Okay, I'm trying to picture 40 cups. I mean, I can picture 2 or 3 cups, maybe even 4, but how much is 40 cups? So is cups the best unit of measure at this point in time?
No.
No, we should probably switch to
Gallons.
gallons, right? And this one I have a hard time with, so I'm just gonna write down some stuff I know off the top of my head with our crazy measurement system. I'm pretty sure that 1 pint is 2 cups. And then, let's see, there's 2 pints in a quart. So 1 QT quart is 2 pints. And then there's 4 quarts in a gallon. 4 quarts is 1 gallon. For some reason, I can never remember how many damn cups are in a gallon. Okay. And so my recollection, since I'm going from a small unit of measure cups to a bigger unit of measure, I'm going to have to multiply those cups to get into a gallon. So I'm pretty sure I've got 2 cups times 2 pints times 4 quarts. I got that right? 2 times 2 is 4 times 4 is 16 cups in a gallon. Seem reasonable? I think that's right. Okay. When I'm completely confused and I have internet access, I Google it. So cups in a gallon, just to double check, it says, Google says 16 customary cups. Okay, so I got that right. So I want to convert using this new information. So I now have 20 cups per minute as my rate. I'm going to go with my unit rate instead of my modified rate. So 20 cups per minute, 1 minute. And I'm converting to gallons, so cups has to go on the bottom, right? And we just found 16 cups go with 1 gallon. So to get rid of cups and change to gallons per minute, I do a division. 16 over 20. Now, my recollection is 16 is pretty nice to divide by, so whip out your calculator. What's 20 divided by 16? I think it's like 1.2-ish. 1.25, that's close, okay. So 1.25, and what are the units of measure on that number? Gallons? Almost. Gallons per minute, right? Because this is still a rate. So gallons per minute. And Matt, did you have a question or you just stretch on there? Okay. So we've redone this now. So now I got it in gallons per minute. Okay. A minute goes by, I lose 1.25 gallons. A gallon's a pretty darn big thing of water. You know, it weighs, how much does a gallon weigh anyway? What's that?
It's like 8 pounds.
8 pounds in a gallon? All right, let's see. How about pounds in a gallon? You're right, yeah. At 62 degrees Fahrenheit. Yeah, that matters. Also, it matters whether it's at sea level or not. Because when you go lower, right, the atmosphere compresses stuff. When you get higher, stuff expands. So it turns out you'll get slightly different, you know, minuscule amounts different, but there are different. If the temperature or the pressure is different, which means altitude is different. Anyway, so yeah, it's about like what Jenna said, about 8 pounds in a gallon. So I just lost 8 pounds of water. Okay, so in my house, there are 4 of us. And I've observed everybody spacing out and doing that. So I want to figure out with the 4 of us what happens in a week. Okay. So let's bump this up a little bit. So 4 people. So I multiply that by 4, right? But then 7 days go by, right? So times 7 days. All right, 4 people times 7 days. That's 4 times 7 is 28 times we lose this. Now, does everyone just brush for 1 minute? No, let's say they brush for 2 minutes, so I got to multiply that by 2 also. So we're going to take that, was it 1.25? And I'm going to ignore units just for a second. Times 2 minutes, times 4 people, times 7. Somebody help me out with that calculation. What's that lead to? What does that matter? 35. So that's 35 gallons of water.
I think it's 70.
You think it's 70? You missed a 2 there? Yeah. Sorry, 70 gallons per week for my family. Gary's family. If we all space out. Okay, 70 gallons is a lot. That's just brushing our teeth, right? Never mind, like you go to get a drink of water, it flows for a little bit. You're washing dishes, it flows for a little bit. What else do? We need water, we might let it go a little bit. Washing your hands, what was that? Shower. Yeah, I was thinking about that this morning. I was like, oh, I bet I can find a flow meter I can hook up between the shower head and where it comes out. Yeah, and it'll tick away. I remember my kids came home with a kit once from elementary school. Remember that? Yeah, you're supposed to try to measure water usage in your house. They give you low flow devices and stuff to see the difference. Yeah, I'm gonna have to do that soon. I'll look that up and report back. So 70 gallons. So, okay, I know how big 1 gallon is. Is anyone having a hard time picturing what 70 gallons looks like? Tristan's dying, and I was like, 70 gallons.
Yeah.
What's that?
Like the milk section at Walmart.
Like the milk section at Walmart? Yeah, no doubt, right. Yeah, picture that. Milk section, there's gallons, there's half gallons in a rack. Yeah, there's probably 70 in a rack. That's probably a whole rack, 6 feet tall, 2 feet deep, 3 feet deep of liquid. So just to double check to change this to like a size of something, we can see how many cubic feet or gallons are in a cubic foot. So let's do one more conversion. Gallons to feet cubed. What is it? It's on there? Yeah, my recollection is like it's pretty close to 7.5. Yeah, so let's just use that. Okay, so let's go back here. So let's see. I usually have to write this down a couple of times before I get it right. In 1 foot cubed, right? So a foot by foot by foot box kind of thing. There are about, wavy equal sign for about, 7.5 gallons. So then, let's see, converting my 70 gallons, I'll have to multiply by a fraction with the 7.5 gallons in the bottom, so I can change the cubic feet in the top. So cubic feet or feet cubed, whichever way you want to write it. So 70 divided by 7.5 is going to be like 9-ish, I think. Anybody with a calculator?
It's 9.3.
9.3-ish, it repeats. Okay, let's just call it about 9.3. So that's approximately 9.3 feet cubed. So imagine you're in a shower stall that's 3 feet by 3 feet. That's about 9 square feet, right? And then, so the water my family uses would fill that shower stall 1 foot deep with water. Kind of a lot, you know. Imagine if all that water got out onto the floor. That'd be a little problem. Okay. I think that's it here. So I just kind of wanted to warm up with how to use the conversion factors. On the homework, if you don't use the conversion factor on that sheet, if you pick a different one, for example, this sheet says, let me show everybody online, miles to kilometers. What does it say? There's 0.62 miles in 1 kilometer. Yeah, I'm used to remembering that there's 1.6-ish kilometers in a mile. So for example, I did a homework problem using that number instead, and I came out like 1 decimal place off. The answer is supposed to be 7.55. I got 7.54, and right, so it marked me wrong. So if you do find yourself a hair off on something, just send me a note in the homework saying, hey, I think my answer's good. Here's why. Otherwise, redo it with one of their conversion factors. Because the bottom line is the rounding is going to be a little bit different. So for example, I remember that there's 1,609 meters in a mile, right? So let's play with that for a second.
When, like, on the prep, when you retry it, it gives you this, I'm getting the same question.
Yeah, for some problems, it's hard to redo them with different numbers. So sometimes you'll get the exact same question again.
So I had the right answer, everything before that you've been writing as a fraction, so
Yeah.
I assumed you wrote that one as a
And
fraction.
one of the
but you
decimal
did-
instead.
No, just, it was 4, but I put it as 4/1.
Oh, 4/1 versus 4, yeah, right, gotcha. So let's see, my recollection is that there's 1,609 meters in 1 mile. And so if I wanted to rewrite this for kilometers, for example, like what is 1 kilometer in miles? So I want to do a conversion, my goal is miles. I'm going to have to multiply by a fraction here to get rid of, random mark, interesting. To get rid of kilometers. Now I can't change, based on this fact up here, I can't change directly to kilometers because that's in meters, right? So I would have to first change kilometers to meters. Does anybody remember what kilo means? Went over that last week sometime. It's 1,000. So there are 1,000 meters in 1 kilometer. So multiplying by 1,000 will allow me to change this to meters. So now I can use this fact up here by saying their meters goes in the bottom, miles will now go on the top. There's 1,609 meters, pretty darn close, in 1 mile. So this tells me in order to change kilometers to miles, I should multiply by 1,000, then divide by 1,609. So whip out your calculator and see what you get when you do that. You should get 0.6 something.
Number 5.
Sure. So let's see.
0.6215.
0.6215. So it's pretty close to the book. The book says 0.62, right? So can you see there's a slight difference depending on which version of the measurements you choose. And you know, that's just life. Everything's not the same. We have to round stuff. So I'm pretty close to what the book says, which is 0.62 to the nearest hundredth of a mile. Okay, so on paper, we'll get slightly different answers. Sometimes that's a pain in the butt on the computer because the computer is looking for an answer that's maybe closer than we state. All right, so question on number 555. Okay, so that's a good one. So I'll do this one, then I'm going to set you guys free to work together. Blow it up. So you're driving in Canada and it says you can go 80 kilometers per hour. How many feet would you travel if you went 4 seconds? Okay, so I'll write that information down and then you guys are going to help me based on the conversion numbers in this chart back here, how to change. So over to my sheet. So I want to take 80, let's use a different color, 80 kilometers. And generally when I'm using conversions, I write them as fractions per 1 hour. So I like to write it like that. And my goal is to state this, let's see, they want to know what, how many feet we travel in 4 seconds? Okay, so we text for 4 seconds. Yeah. So my goal is to change this to feet per second. I'm not going to worry about the 4 yet. I'll just get it down to 1 second, and then I can deal with the 4 part in a minute. So let's see. Hours, let's get rid of that first, because that's kind of the easier one to deal with. So hours is going to have to go in the top. Now, I've done these conversions so many times that I think about it for a second. There's how many 60 seconds in a minute, 60 minutes in an hour. So doesn't it make sense that there's 60 times 60 seconds in an hour? So that's 3,600,
Yeah.
right? So in 1 hour, there's 3,600 seconds. So I could either have 2 fractions of 160, or I could just have the 3,600. So next I have to get rid of kilometers. So looking at that cheat sheet, what's going to be helpful in getting rid of kilometers?
0.62 miles.
Yeah, I guess it's the 0.62 miles in a kilometer. Yeah, so we'll use that one next. So this gets rid of what? Hours is now gone. We need to switch colors. Next, I'm going to get rid of kilometers, so that goes in the bottom. Let's move my goal out of the way here. That's what I'm hoping to get. And let's see, that conversion factor is in miles, right? Miles is 0.62, kilometers is 1. I put the numbers in the right spot? Okay, so I'm getting closer. I now have kilometers, so next I need to get rid of miles by changing to feet.
52.8.
Yeah, and miles has to go on the bottom. 1 mile is 5,280 feet. So now miles is gone. So remember, whenever you have one of these, anything in the top gets multiplied, anything in the bottom gets divided. You can ignore any ones. So I'm going to take my 80 times 0.62 times 5280 and then divide by 3600. The order does not matter.
So you think it's just like taking one thing and breaking it down
Mm-hmm.
to get weight.
Yeah, and you could do it one step at a time and calculate, one step at a time and calculate. And I just find it easier in the end to just start crossing stuff out and then just do my multiplications and divisions in one shot. But I consider it one fraction at a time as I move through to get an answer. Yeah. So we'll do another one of these, which, yeah,
290.98
290.98.
would be feet.
So like if we were like whole number
Well,
of we call it 291.
Yeah, that's that. Then you got to times the 4 seconds after when you get
So
at the end.
291 feet per second, approximately, per 1 second.
How do you get that?
Okay, so let me bring out my calculator.
What do you do?
So clear. So I'm starting with 80, right? And my fraction says and you could do it in the order you see them. So this fraction says divide by 3600. So I just go to my calculator, there you go. And I hit divide by 3600. The next fraction says multiply by 0.62. And the next fraction says multiply by 5280. And I get, oh shit, a different number. What did I do wrong?
No, then you got.
Oh, you already multiplied by 4. Okay, you were way ahead of me. Okay, so it's like 72.7-ish for 1 second. Yes, let me correct what I wrote down there. Robert was ahead of me. I wasn't paying attention. Erase. So we've got about, what was it, 72.4? And I mentioned it doesn't matter the order you do those in as long as you get the multiplication or division part right. So when usually what I do is I look at the numerators first. So I was thinking I should take 80 and multiply by 0.62 and then multiply by 5280. And then I get around to the division stuff. So I divide by 3600 and I should get exactly the same answer. Okay. So the key with the conversion factors is something ends up in the top, it's a multiple. Something ends up in the bottom, you divide by it. And it could be you divide by multiple things. It just kind of depends. Okay. So that's what happens in 1 second. And then if we multiply that by 4, we get about 291 feet in 4 seconds. So that is about 291 feet in 4 seconds. So if this is like a rural neighborhood, it's 80 miles per hour. 80 kilometers per hour. Anybody know about what that is in miles per hour?
Yeah, 49.6.
Yeah, it's almost 50 miles per hour, right? And we can use the conversion factor, the black conversion factor here to figure that out. 0.62 times 80. Comes up to almost 50 miles per hour. That's pretty darn fast, right? So we do that on back roads around here. In rural areas, 290 feet would probably be like the width of somebody's front yard. Lots tend to be wider. So you just pass somebody's house in 4 seconds at that speed. That's pretty darn fast, right? A lot can happen in 4 seconds or in almost 300 feet. Okay. Now let's look at this slightly different. So let's stick with our 72.4 for a second. I was talking about this with some teenagers the other day, and some of them say, oh, I'm fast on my phone. It only takes me 2 seconds to look at a text, right? And other people are like, oh, I'm gonna think about it. Maybe I might touch the screen. So some people might do it for 2 seconds. Some people might do it for 6. So I'm just gonna get a range of what people might do on this. And we're going to stick with the 80 kilometers per hour, which is about 50 miles per hour. And have a low of a 2-second look at your phone and a high of a 6-second look at your phone. So would you agree to make that happen? All I have to do is take this number and multiply it by the number of seconds. Right? So if I double that, that's going to be like around 140 feet, roughly. So the, oops, wrong way. So the low end here is about approximately 140 feet went by in 2 seconds. The high end, if I multiply that by 6 times 7 is what, 42? So it's going to be like 420, 430-ish. Did you get a number, Aaron? 434. 434, okay. So in the upper end, we've got something like 434 feet went by. And our measurement of 300 sits kind of in the middle of those two, right? Because that's 4 seconds, should be right in the middle there. And there was a question later here that says, hey, can you state a typical time? I think, is that what it said? I'm using different numbers than it uses.
Typical texting response or something.
Let's see, that was, okay, number 6. Yeah, typical texting response is between 2 seconds and 60 seconds. Now they said use 35, we're using 50 miles per hour. So we're getting a different set of numbers, but your answer is going to be written up in a similar way. So for this one, you're supposed to write a sentence. It's saying the typical distance is going to be between, maybe it's 100 and 300, right? So we have to recalculate those. And then the next part says express it as an inequality. So I'm going to express the inequality. You guys can totally handle the sentence there. What I would say, let's erase this part. I would say the distance is going to be less than 434, and the distance is going to be greater than 400. And this is called a compound inequality, and you always read from the variable. The variable here is the word distance, right? Because some people look for 2 seconds, some people look for 6, some people do it somewhere in the middle. So the distance varies. If I read from the variable, and it might sound stupid, but this has always helped me in math, figuring out whether it's less than or greater than, the monster eats the bigger piece, right? So when I read it, distance, and then that symbol, the bigger piece is pointing toward distance, so this says distance is greater than 140. When I read it the other way, this says distance is less than 434. So a compound inequality just throws them together. Okay, the distance is somewhere in between. So that's one way to write it. The other way to write it is to just state it in 2 different parts. So you could say the distance has to be bigger than 140, and the distance also has to be less than 430-ish. So 434. Okay, so you have 2 ways to state it. With an and connecting 2 inequalities, or in one big inequality called a compound inequality. And we'll use those some more later. All right, so I would like you guys to finish up this, and I'd prefer you find a partner to do so. Part of this activity is going to require you to measure this room. So I brought some measuring devices. So Daisy and Jose, since you're not in the same room as us, you're going to have to pick the room you're in. Now, if either of you happen to be in the open area in Hermiston, that would be a bad room to pick because it's wicked huge. So you want to pick a different room. And so later on in this thing here, keep going. You're asked to just look around the room you're in and say, how long is this room? You decide which one's going to be long, this way or this way. And then look down at the floor. How many square feet are in this floor? And then look at, how big this room is, how many cubic feet of air is in this room. So you're just going to make a wild guess. Don't worry about being right or wrong. So that's what happens on number 7. You're also supposed to make the same guess for meters. right? Anybody want to guess how many meters tall this room is? 3, I think it's about 3 also. Yeah, pretty darn close. And we'll measure that in a little bit. Yeah, and then on the next page, you're actually going to start measuring some stuff. So I brought some tape measures here that have both centimeters, let's see, centimeters, meters, inches, and feet on them, depending on which side of the tape you look at. For Daisy and Jose, if you guys don't have access to a tape measure, let me know and I'll get one over to you. But you want to ultimately sometime this week get access to a tape measure to measure whichever room you happen to guess at first. And so you definitely want to make your guess first. So those of you in this room, skip over to this part right now. Question number 7, and just make a guess. When I think about length and width, I usually want the length to be longer than the width. I don't know why, it's just this preconceived idea I have. So guess at how long this room is. And then at some point before you all leave, grab one of my tape measures, grab a partner, and start measuring some stuff. Here's the tape measures. And then otherwise, just ask me if you and a neighbor can't figure out the answer to one of the questions on the worksheet that we haven't gone over yet. I think we've gone over most of the kinds of problems you see on there. All right, have fun. Daisy or Jose, if you have a question, text here or chime in with voice.
What's the calculation for volume?
Volume is length times width times height.
Okay.
Yeah, I'll write that down here. Length times width times height is volume.
Is it area based?
Area is either base times width or base times height, however you want to call it. Yeah, so it's 2 measurements multiplied together. So another way to think about volume is if length times width is the area of the floor, volume is just area times height, would be another way to think about it. And key, those measurements have to be in the same unit. So if you start doing 1 in feet, they all have to be in feet. If you start doing 1 in meters, they all have to be in meters. If you do 1 in inches, they all have to be in inches, right? You can't mix them up. They're all going to be the same. Otherwise, you get nonsense. Okay, let's see. When is this worksheet due? I'm hoping to get this worksheet tomorrow, Jose. And I didn't finish grading everybody's 1-4 worksheet. I'll get those done today and get them back tomorrow to you. I will be right back.